Good morning. My name is Miloš Jakubíček, and I'm very happy to have an invited talk at AFRILEX. I'll be talking about automating dictionary production. Before I start, let me introduce myself quickly. I've taken over Lexical Computing, the company behind Sketch Engine, a corpus management system some of you maybe heard about, after the founder of the company and my dear colleague Adam died in 2015. I'm very happy for the invitation to AFRILEX because that's one of the world in lexicographic events that I never had the opportunity to attend so far, and because of the pandemic, this talk is a virtual one as well. But I do hope to come from Europe in the next years, and I'm very happy to have the opportunity to present the work we do at Lexical Computing on automating dictionary production today. I will start with some historical overview in terms of how I see that things developed and where we are at the moment, and how far can we actually get. I see dictionary production as a process that requires some input data, tools to work with the data, and people to make sense of the tools and data, basically. And I will reuse Michael Randall's concept of corpus revolutions here to describe what I see as 3 steps of utilizing corpora in lexicography. Before corpora got available, lexicographers had kind of nothing but their own introspection. And we all know about the disadvantages of that approach and difficulties that lexicographers had to face in their work. Getting a corpus is quite a transformational experience that my dear late Adam once at the AFRILEX described using these 2 images, and he was saying, when I think about language, I feel like being the big brain at the left side of your screen. I get lots of interesting theories and ideas and hypotheses, how things work or might work or would work. And then I look into the corpus and I feel like the Homer Simpson on the right hand side of the screen because almost inevitably I find myself being wrong. And that's the purpose of having a corpus, basically. It provides elementary statistical evidence, input data for anyone working with language. And lexicography from the very beginning has been a driving force in corpus linguistics, and corpus linguistics and corpora are owing to lexicographers a lot because the early development was very much associated with dictionary building. Just to remember projects like the British National Corpus. When you have a corpus, you start reading, right? And that was not quite a big deal in, say, 80s. My colleague Michael Randall remembers, when they were interrogating the co-built corpus, they simply asked person that was managing the very big device in a very big room, which was called a computer, to prepare them a concordant slip in the evening. And they've got a couple of papers in the morning at their desk that were describing the use of some English verb that they were searching for. However, corpora soon, fortunately, became so big that they are no longer meant to be read, too big to be read. And if you try to read a corpus, my one of my colleagues was typically giving an example of reading a 1 billion word corpus, which would take you approximately 60 years if you would be doing that 8 hours per day with some necessary breaks. So there were tools needed that were processing and analyzing the corpora so that people will no longer need to read the corpus. And those tools were developed so that they would eventually understand the data better and be able to extract data from the corpus and know what's the difference between extracting data and extracting a tooth. And that step can be illustrated, for instance, on a word sketch, on a short overview of words, collocation and behavior in a corpus, where you get digested information automatically out of the corpus, but there is evidence provided and evidence kept of the original text, so that you can check whether what has been automatically found is really backed with the right data. And the third step that I'd like to talk about is automatic dictionary drafting, where you have a corpus and you have a big corpus. And you've got plenty of tools to work with the corpus, and you are able to generate a dictionary draft automatically and potentially post-edit individual entries manually. From a technological point of view, this is just evolution. The tools available for processing of corpora, like part-of-speech taggers, lemmatizers, syntactic parsers, tools for things like finding good dictionary examples, identifying word senses, etc., were gradually getting better and better into a situation where for many languages those tools provide results that are precise enough so that the output can be used either with no subsequent human correction post-editing or with rather minimal effort. Methodologically, however, this is a revolution and rather a big one. And in this talk, I will try to focus on this methodological aspects of post-editing lexicography rather than the technological details, because as we were using this approach in several lexicographic projects, we have identified that the methodological challenges and managerial aspects are really surprisingly big, even for us, very surprisingly big, and they really present much bigger challenges than, as I believe, any of the technology that is necessary for such a task. I think that lexicography can take quite many lessons from post-editing in machine translation. In machine translation, post-editing was introduced too early. I think when it started, the technology was simply not mature enough for it. The translators were so the automatic translation was producing quite a lot of errors, so that frequently to post-edit machine translation was more demanding than to translate from scratch. It was pushed hard by translation agencies. I remember translators, professional translators, talking about direct cost cutting from translation agencies through machine translation post-editing. While the processes and the methodology for translation was initially not adjusted at all. It was simply seen as, this just makes your task easier. We let the computer translate, and then you just fix a few errors here and there, and then that's it. And it was not understood at all as some type of substantial workflow change. But it was quite a change, and I think the same applies also in lexicography. The result for machine translation was that translators got furious about post-editing. It took very long time until it became an established practice, and not only established in terms of the business perspective, but also appreciated service by translators. It is still seen as somewhat problematic, even though the quality of machine translation for many languages is really so high that it is significant help for translators. And it is even seen as problematic for, say, the impact it has on the. And it is still seen as problematic by many translators, even though if you look at the global data, they show that the whole translation and localization market over the whole world is just growing thanks to it. So there are more and more translations being carried out, and there is more work even for humans in translation. Not despite machine translation being introduced, but actually thanks to machine translation being introduced, because it actually makes it affordable to provide post-edited machine translation where it was not affordable before. More and more data is being localized in information technology and also otherwise. So even though the typical fear of translators of losing their jobs is by far not happening, it's rather vice versa. Machine translation is still seen as problematic by some of them, and I think from all of this we should take lessons for lexicography to avoid repeating the mistakes, because from a certain perspective I see that we are in the same position as machine translation was maybe 10 years ago. Well, what I want to present here as a couple of ideas and hypotheses is that the post-editing lexicography is not just automatic dictionary drafting in terms of having corpora and some new technology, but in the first place it means development of tools that specifically support efficient post-editing of the dictionary drafts. It requires development of quite a new methodology that accounts for post-editing. It requires a lot of teaching and training of the editors, talking, explaining, being patient, so that the editors actually identify themselves with the new processes, that it makes sense for them, that it actually helps. I think it is important to understand the impact of understanding a modern digital dictionary using this triangle description. From my point of view, the biggest impact lies in the fact that some of the rather difficult lexicographic decisions that editors had to make at the time of making a dictionary are now gone. Are now no longer needed, and instead they are simply moved into the time when the dictionary is actually used by a user or by a machine. And this relates to things like that you no longer need to decide on things like where exactly should this multi-word expression or idiom belong. Because you no longer have the printed dictionary where you would need to choose just one place, or you would need to duplicate the information at the cost of having simply endless paper available. And you also don't need to worry about the presentation, like what should this look like and how should I organize it to the user when making the dictionary. All of this is now carried out by a separate search engine at the time when the dictionary is used, possibly having much more information about the type of user and context of use than one can have when making a dictionary. A different visualization and presentation option will be chosen when the dictionary is used on your mobile phone or tablet, a different one on a web page or in a integrated third-party dataset or tool for whichever purpose it serves there. Okay, I'd like now to present a particular business case that we were carrying out in the last 2 years at Lexical Computing, and that was focusing on creating 3 dictionaries from scratch, 3 bilingual dictionaries from scratch. The 3 dictionaries had Tagalog, Urdu and Lao as the source language, and the English and Korean as target languages. They were created fully from scratch using an automatically generated dictionary draft, and part of the dictionaries were later post-edited manually. When I say part, it was 15,000 entries out of the 50,000 entries that were altogether created. 35,000 entries were left entirely automatically produced. To explain mainly why one of the target languages was Korean, we were doing this work for Naver Corporation, a big Korean company, something like a Korean Google, where the company provides web dictionaries for their users in the same way like many other big technological companies provide for free. I'll start by explaining the entry structure of the dictionaries. It was quite standard. You will not be surprised, I think, by any part of the entry. An entry was consisting of a head word, a list of inflected forms where it made sense, an audio pronunciation, and then for each sense of this head word, we were providing some short disambiguating gloss, up to 10 collocations, up to 10 synonyms and antonyms, a picture if appropriate, 3 example sentences, an English translation of the gloss and one of the examples, and also a Korean translation of the gloss and one of the examples. The input and the whole recipe for the dictionary here, I think the numbers come from Tagalog, was in theory quite simple. You start with a big web corpus. For Tagalog, we started with a corpus of 650 million words that we've crawled from the internet. When we were working with the corpus, despite some initial cleaning was performed that we do for all languages, we had to remove 2/3 of the corpus because we have identified it as machine translated content. So at the end, we were left with 230 million words, which I think is quite so for the size of the dictionary, and certainly lots of things would be easier if we had more data, but it was doable even with such a big corpus. Generally, I think that for many low resource languages, this the size of the input dictionary, the size of the input corpus will be a big challenge. For say European languages, you typically don't get such a big portion of machine translated content because for business reasons it pays off for the corporations to not to use machine translation and have web pages fully translated. Also, what I see as a big difference is that in some countries, as I see it, the internet got widespread already at a time when social media existed, and the say first generation internet, or I don't know how I should properly call it, was simply skipped there, and as a result of that, for many languages, most of any textual content is available just on social media, where it can't be crawled both legally and technically, and it's simply not available for lexicographic purposes. In some countries, even public institutions don't have a web page and they just have a Facebook page, which for a European is quite unthinkable. And the same goes for schools and companies and so on. So getting a reasonably big corpus was quite a challenge for all the 3 languages. If we would be dealing with Dutch or German or French, this would be a much easier task, and the size of the corpus would make lots of additional processing easier. We had a post-tagger and lemmatizer for all 3 languages that we have partially developed ourselves, and we've partially reused some of the existing tools. We have created a sketch grammar, which is kind of a description of morphosyntactic relations for collocations in the corpus. We have loaded the corpus in Sketch Engine, which is the corpus management tool that we develop. We have used Lexonomy, which is a simple web dictionary editor that allowed us to set up dedicated interface for each of the post-editing tasks that I'll be talking about later. We had 1 to 8 developers working on it, depending on the amount of work involved in different stages of the project. Clearly you don't need that many from the perspective that we were doing this for the first time. If we would be doing now the 4th one, it would be likely a job for 1 technician in terms of the assistance. We had 5 to 15 editors, again depending on the type of lexicographic work that was involved. The overall editorial workflow was as follows. We have started by generating headwords out of the corpus. Then we've been working on the inflected forms and audio pronunciation. We had tools to provide automatic word sense induction. Having the word senses, we were continuing with images, the thesaurus, example sentences, and finally translations for all the necessary entry parts. I will describe each of these steps in detail. For each of the steps, however, the workflow was similar in the sense that we have always first generated the data fully automatically, and then a certain portion for the 15,000 entries was manually post-edited. The editing tasks were always designed as small, single, and very focused. So the editor was always working on 1 task only, dealing with one part of the entry. It required quite substantial training. We've always started with multiple annotations, at least for some smaller portion of the data, so that we could measure the inter-annotator agreement among the editors to check that they have actually understood the instructions correctly and they can work with the tools and so on. The tasks were technically designed as say work batches inside of the Lexonomy dictionary editor, and we have created a dedicated interface for each of the tasks that I'll be showing later. For the Tagalog corpus, as I said, we were left with over 200 million words. We've customized the Stanford post-tagger, improved a stemmer that is available for that language to provide lemmatization. We have created a sketch grammar. Then we started with generating headwords. That's technologically, of course, a very simple task, because you basically take frequency list of the corpus. We didn't use raw frequency. We use document frequency because that, in our experience, is a more reliable measure for lexicographic purposes. Then for the first 15,000, for the most frequent 15,000 lemmas in the corpus, the editors were presented with such a decision making, say, instruction graph to verify that we have actually got a valid head word list. And I think starting to start with a really good head word list is very important for the overall post editing scenario, because of course if any noise that remains is then likely to fail at later stages of the automatic dictionary drafting. If you look into the graph, it's nothing complicated. We were basically verifying that we've got a valid head word, and we were classifying some elementary named entities. In the Lexonomy dictionary editor, this was designed as kind of a flagging option in the entry list, where editors used keyboard or mouse to go through a list and mark the entries using the classification that you've seen before. For the inflected forms, we use the automatic lemmatization that we had in the corpus, that we annotated the corpus with, and that lemmatization provided us with an automatically generated list of lemmas and related inflectional forms for at least for Tagalog and Urdu. Lao is not an inflected language, so this step was omitted there. The task for the editors was then simply reassigning lemmas for inflected forms where the lemmatizer made an error. From the methodological perspective, this is not a very problematic task, of course, and typically there is quite a high inter-annotator agreement on it. Next, we have been recording the pronunciation. This is actually the only step. I've been saying all of them were first automatically drafted and then post-edited. That's not true for the pronunciation. That was the only step that was not automated in any way, because there is no way how to post-edit an audio recording. You can just make a new one, and we have realized that this is really a smooth process. This is our recording booth in one of our offices, where native speakers were recording the pronunciation for the individual entries, and as we have identified, even with some necessary breaks, they were able to record the pronunciation for about 800 words per day. So this is actually a very quick and smooth process. You likely don't see that very clearly, but the editors were simply presented with a head word to pronounce. After they have pronounced the head word, the recording was replayed to them, and they had to confirm that it is correct, or they had the option to re-record or skip in case they wouldn't be sure about the pronunciation. The next step is word sensing identification, and typically this is seen as one of the most difficult tasks for say from the natural language processing perspective, and also of course from the point of view of making a lexicographic decision. We have actually realized that technologically this while this is by far not a problem solved, then the current technology is completely sufficient for employing this into the whole post-editing workflow. The approach we have taken, and certainly it's certainly not the only one that one can take, but the one we used was that we use a clustering algorithm that clustered individual concordance lines based on the word sketches for a particular entry, and using word embeddings, a method for basically putting words in a corpus into a vector space. So we use a clustering algorithm to cluster individual concordant signs, individual corpus occurrences based on the word sketches into separate clusters, where each of the clusters would ideally represent single word sense. Now, of course, there's been a great lot of errors, but what we have realized is that from the post-editing perspective, the most important thing is that the clusters are not mixed, that each cluster actually consists of just a single sense, because then it is very easy very easy for the editor to perform the kind of lumping joining of the clusters, and just putting the right clusters together and saying, okay, this represents a single word sense. And the second thing, of course, is that all the clusters should cover all the word senses, and that's actually much harder to achieve for some low frequency items. The editorial interface, the post-editing interface for this task looked as follows. So the editors were provided with a set of clusters, and they had to assign numeric labels for each of the clusters, where the numeric labels correspond to the individual word senses. So in this case, they have said, okay, both cluster 1 and cluster 2 correspond to the same sense, number 1. They had to provide a disambiguating gloss for the sense, and we used machine translation to translate the disambiguating gloss automatically, after which they had to double check the translation and possibly post-edit it. As you see, they also had some additional information about the clusters and collocations available. A cluster here is a set of collocations or collocates. Each of the collocate is associated with a corpus link and with information about which type of relation it stands in with the original head word. Having word senses, we basically continued with the rest of the entries. We were automatically providing pictures for each sense, where we used the head word and the disambiguating gloss for each sense to search in some publicly available image repositories. We used Wikidata and Wiktionary and Wikipedia, basically all of these Wikimedia projects which provide images completely for free. We use Pixabay, which is also an open database, and we use Google Custom Search, where you can limit your search for images that are licensed for commercial use. These three data sources are certainly the ones that I can recommend from the perspective that you get pictures that are either copyright free or where you know that you don't infringe on anyone's copyright, that the copyright for commercial reuse has been granted. This is the interface for the post-editing of the pictures. So the editors were simply required to choose the best picture out of I think 5 to 10 that were automatically provided for each sense. They picked the picture and that was it. We provided collocations for each sense, and that's been quite simple because that's one of the core functions of the sketch engine software. So because the corpus was part of speech tag and lemmatized, and we had the sketch grammar, we calculated the word sketches, the collocational profiles in sketch engine, and generated collocations. Again, collocations were subject to subsequent post-editing, but from the point of the post-editing task, this was a rather simple task. We also generated a distributional thesaurus from sketch engine. Because we had the word sense disambiguation already done, we were able to generate the thesaurus not just on word level, which is what you typically get in Sketch Engine, but also on sense level. So we were able to actually obtain thesaurus items for different senses. A distributional thesaurus is basically a list of semantically related words that are not classified into synonyms or antonyms. This is something that was then done by the editors in the post-editing step. Example sentences were obtained using the GDEX module that is again part of Sketch Engine. We were generating up to 10 example sentences automatically from the corpus, and the editors had to choose 3 to 5 out of this set that they found appropriate. For the translations, we used Google Translate and Microsoft Bing. The reason for using both for translating the disambiguating glosses was that Google Translate provides only a single translation, while Microsoft Bing can provide several candidates. Overall, our impression was that Google Translate works slightly better, certainly for the translations into Korean, but we wanted to provide as many translation candidates during the post-editing phase as possible. I must say I'm not quite sure whether using Microsoft Bing was such a big help, because typically the translation candidates or alternative candidates were just different inflected forms of the same word, but sometimes they actually also picked a different sense, and we wanted to have it there. So we used both for the disambiguating glosses. We used only Google Translate for translation of the examples, where no alternative candidates were actually useful during the post-editing phase. On this slide, you can see the overall workload that was required on the example of the Tagalog dictionary. As you see, it's taken altogether over 7,000 person hours, which one can translate into something like 3 to 4 months work for a team of 5 people. For the following 2 languages, we've started with Tagalog, and then we've followed with a 3 months delay with Urdu, and in another 3 months we've started with Lao. So for Urdu we needed about 20% less, and for Lao again 20% less than for Urdu. So as we were getting more experience with the overall post-editing workflow and organizational issues, less time was simply required. So I'm quite sure that the next language we'll be doing will require less than half of the time that was necessary for Tagalog. From the table you can see that the most demanding task was actually examples and their translation. That was quite a surprise for us. We were expecting this, as I already said, that the biggest issue would be the word senses and the overall word sense business. And it turned out not to be the case. We rather had issues with the examples where it took some time until the editors that we have trained fully understood what constitutes a dictionary example, which is of course not an easy task. And also throughout the translation process, we had to deal with issues like translations changing the part of speech and etc. The 7,500 person hours translates, depending on the dictionary, into something like 150 to 250,000 euros, which I think is actually quite quite a good price considering the size of the dictionary and amount of information that is in it. And additionally, as I said, I think the next one would be quite cheaper than that. Let me finally discuss the lessons we have learned from it. We are really quite sure that the biggest issues relating to automatic dictionary production and post-editing are not technological ones, but they are rather in the, say, crowd and data management. We have quite a lot of experience with dealing with corpora and textual data in general, and still it took us quite a while to find a good way of managing the original data set, the automatic annotations, and all the post-editing changes to the data. You get into the type of issues where someone makes a correction to, say, part of speech tagging of an individual entry, and that of course then impacts subsequent processing, and the corpus basically should be updated because of that. The technology is certainly mature enough to be beneficial. What is necessary is to do a lot of training with the editors so that they actually identify themselves with dealing with the automatically produced data and post-editing it. We have been dealing with 3 languages that none of us, as say the software developers, of course, speak. More than that, Urdu and Lao don't even use Latin script, and it required really a lot of time to simply to look after the editor's shoulder to double check that there have been no major technological processing errors that can easily harm the whole automatically drafted data set. A good and big corpus is really the best start of everything, and I just can't emphasize it. I think half of the issues we wouldn't have if we had a bigger corpus, but we were simply unable to make a bigger one. We've been crawling data for all the 3 languages for months, and we were getting really a lot of noise, a lot of machine translated content. I'm afraid this will be the case for many less resourced languages, and it really made many of the tasks, good example finding, providing a good thesaurus and so on. It made it much harder. I think that on the other hand, for many low resource languages, a lot of the post-editing tasks can be simplified so that an educated native speaker can carry the tasks out. So you don't always need a lexicographer with 30 years of experience for things like classifying synonyms and antonyms. That's a concept. I said that the amount of time involved would correspond to something like 3-4 months for a team of 10 editors, but that of course doesn't mean that it took us just 4 or 5 months. Not only because almost none of the editors that we had was working full-time, but also that we've really had big issues to legally employ native speakers from those countries back in Czechia, and that's a sort of lesson learned that probably will not apply to you, but for us it's been really quite an experience. It took us months to get through the admin in some cases. Also, the COVID crisis was not helpful. In this. But all 3 dictionaries are finished by now and available online. The conclusions on the whole topic are rather simple. Is post-editing feasible? Absolutely yes. I mean, almost all of the steps, I mentioned pronunciation as an exception, can be efficiently automated and then post-edited. Where when I say efficiently, I mean it saves time and it saves money. And I would even say that for at least some of the tasks, it makes the work more enjoyable. It makes it possible for the editors to focus on the most intellectually demanding tasks and not on the simple things. It is a rather radical change of workflow, really. And I think we are still not done with this. Next time we'll be doing this, we will make some adoptions to the workflow that we used in terms of the overall data management. And I would hope that eventually we would come up with some set of tools that would be available online for anyone using it just out of the box, because so far it was even for us quite a demanding project from the software development point of view. When someone would be asking about the time frame necessary, then I think 12 to 18 months is a safe shot, and anyone who would be wanting to do that can go ahead. What I think is a really good message is that this methodology is suitable for low resource languages. Some of my colleagues said we should have started with something easier than Tagalog, Urdu and Lao, perhaps even with Czech, which is the mother tongue for most of us. But on the other hand, and they might have been right, but on the other hand, thanks to this, we can now say that even with what we see as a modest corpus, say 100 million words, you can go ahead. So, thank you for your attention. We would be very happy to collaborate with anyone who would work on projects similar to the ones that I've presented. I wish you all the best for the AFRILEX conference, and send greetings over here from Central Europe.